In the previous section, we have worked on our map for the game, we have added some lights, and overall prepared our game to test the shooting mechanic that we will implement in this section. So let's get going. First, we should take a look at our sprites folder, since here we have two sprites for our weapons. First one is the assault rifle that we will implement, and the second one is shotgun, which I will try creating an extra video on how to implement when I have uploaded all the content for the base of the course. So we are going to start with our assault rifle, and if you click on the assault rifle object in the sprites folder, you can see that it has a slightly larger pixel per unit value. Now we have prepared our pixel perfect camera, so it will not be a problem, but do mind that if you are creating your own game, it is best to have all the sprites created in the same resolution, so you can set the pixel per unit value to the same value. Since we are using the free assets with the license CC0, we are going to use the version that the pixel perfect camera will produce for us. For now, we should also take a look at the sounds folder, and in the underscore sounds folder, we can see gun sounds. Let's open it up. Here we have a couple of sounds that I have collected that are free with CC0 license, and I have tweaked them a bit. I have added a bit of more bass to them, since sometimes a good sounding weapon might make your players like a particular weapon much more, despite the fact that it is not more powerful, but the sound itself can make the player like the weapon. So this is very important to take into consideration. Okay. With this digression out of the way, what we want to do in this video is to create a sprite of a weapon floating near the player. So what we are going to do is go to the hierarchy, click the player, extend it, and inside the player game object, right click, create, and we are going to create here a game object called weapon parent. So the idea behind this is that we are going to place the weapons inside the weapon parent. We are going to tie the weapon parent to the agent input. So we are going to call a script on the weapon parent to shoot, and this in turn will check if it has a child of type weapon, and if it does, it will call on it to shoot, and then the weapon script will do the rest of the work. But since we always will have this weapon parent inside our game object, we are going to be independent from if we have a weapon in our slot or not. So this will be kind of a weapon slot. Great. So now we are going to open the sprites folder from the project. Let's choose our assault rifle and let's drag the sprite to the weapon parent game object. Now as you can see, it is invisible, it is hidden behind the floor and the player. So choose the assault rifle from the hierarchy, the sprite renderer, and set the sorting layer to be agent and order to be 1. Great. Now we can see our weapon on top of our player. Now the idea behind the weapon is that we are going to rotate it around the player and it will point towards the pointer of our mouse. So that is also the point why we are making this weapon parent, because we are going to rotate this weapon parent. So let's choose the assault rifle child of this weapon parent and let's drag it a bit. Okay. And we are going to make sure that this is a bit further than our weapon parent. We may want to change this setup further if we have longer weapons, but for now we are going to make sure that we have this position, and we would save it inside our weapon parent custom script and then add this setting, so the position on X value to each weapon, so it is rendered just in front of the player. And what we can do is choose our weapon parent and drag it down using the move tool inside the scene view, so that we may want to make it look like our avatar is holding the weapon in her hands. Great. And the idea behind this all is that our weapon parent now can be rotated. So in the inspector, let's choose the rotation Z. Let's hold the mouse cursor on the Z letter, and if we hold left mouse button, drag it, and you can see that our weapon is being rotated around our player, and this is what we are going for. Of course, we are going to rotate it using a script, but basically that is the idea. And that is what we are going to basically implement in the next video. So let's reset the Z value for the rotation, and in the next video let's implement a script that will rotate our weapon according to where our cursor is in the game. So see you in the next video. In the previous video we have implemented a weapon sprite and added it to our hierarchy, but if we press play now and we start moving, our weapon will always be pointing to the right, and we would like it to follow our mouse cursor to point always at the mouse cursor. So let's stop the game and let's implement this logic in this video. What we are going to do is go to our scripts folder, and we will want to create a new C# script. So let's create new C# script, and let's call it agent weapon. Let's open it up in Visual Studio. Great. What we are going to do here is let's delete at the update and start. This will be a mono behavior. We are going to need here a protected float. Let's call it desired angle. Okay, this will be the parameter or the field that we will modify in accordance to what we get from the agent input. So now we will need to create a method that will be able to assign to our agent input event of the onPointerMove event, so that we will be able to get the position of our pointer, calculate the direction, and rotate our weapon in accordance to that. We are going to create a public. Let's call it virtual. In case we want to modify it in a subclass, aimWeapon. This will be the method. We need a void in front of it. So public virtual void aimWeapon, and this method will take a vector2, and it will be a pointer position. Great. So this will be the position of our pointer that we receive from our agent input. So first of all, we will need to calculate the direction. So var aim direction equals, we are going to upcast the pointer position to vector3, pointer position minus our transform dot position, since this will be on our weapon parent, the script. Great. Next, what we are going to do is we want to calculate the desired angle. So let's type desired angle equals mathf dot, and we are going to use a tan 2, passing it aim direction dot y and aim direction dot x, and since this will calculate us an angle, returns an angle in radians, we are going to multiply it by mathf dot rad to degree to calculate the degree value from it. So what does this calculation do? Let's take a look at this example. Here we have a triangle. In this spot we are standing. We are pointing in this direction, and since we can calculate the tangent of this angle, which is the opposite, so the value on y, and the adjacent, so this is the value on x, we can calculate the tangent of this angle. And to calculate the angle itself, we can calculate the arctangent. So the arctangent will give us the value of this angle, and that's exactly what we want to calculate. So that is why we are going to use the method that we have used. So let's go back to Visual Studio. Great. So we have our desired angle, but we still need to rotate our weapon by this angle. So what we are going to call here is transform dot rotation, and we are going to set it to be quaternion, which is used to represent the rotation. We are going to call on it angle axis, which creates a rotation which rotates angle degrees around an axis. So we are going to pass to this method our desired angle, and since we are using the 2D view, we have only the vector3 dot forward to rotate our elements. We are not rotating the objects in x or y, we are only rotating around the z-axis, and that is how we are going to calculate the rotation. And since our weapon is always pointing to the right, its rotation is 0, and any other angle will cause it to rotate in a correct order. So this is what we are going to do here. And to make it work, let's go back to Unity. And before we can assign it to our player, we are going to create a derived class from it. So let's create here a folder in the scripts folder. Let's create a folder. Let's call it player. To organize all the scripts that regard the player, we are going to put them inside our player folder. Let's right click, create a new C# script, and let's call it player weapon. And the reason for it is because our player will have the connection with the UI. So we may want to show how many bullets does our player have. And this is why we need a player weapon. So let's create the script and open it in Visual Studio. Great. Now this will save us some work later in the course. Since we do not have a UI yet, we are going to simply delete the start and update and leave this player weapon as is, but instead of mono behavior, we are going to extend the agent weapon. And now we will be able to reuse all the methods on the agent weapon itself. Let's save it. Let's go back to Unity. And now what we can do is open up our player game object in the hierarchy, choose the player weapon parent, and drag onto it the player weapon. Last thing that we will need to do is go back to our player, select it, and for our agent input, or for the on-pointer position change event, we are going to add a listener, drag our weapon parent, and make sure that it calls an only method that is compatible with vector2 parameter, which is aim weapon. Now, if we press play, we should see that our weapon is following our mouse cursor. And this is great, but unfortunately, you can see in this position, our weapon is upside down. And you can see that in our scene view, our weapon is pixelated, which fits perfectly to our game aesthetics. But I would like to fix this issue of upside down, and as also I don't want to cover up our heroine head with our weapon. I want to render it on the back side of our avatar sprite if we are holding weapon upwards to create this illusion of 3D. So we are going to stop this, and in the next video we are going to fix the way we are rendering the weapon. By the way, if you have the scale here changed, make sure you use the slider to zoom in and zoom out, but you want to be always zoomed out so you can see what players will see. Great, so see you in the next video. In the previous video, we have implemented a way to rotate our gun around our heroine, but our weapon is upside down when we are pointing to the left. So let's fix those issues with rendering. Let's stop the game. What we are going to do is we are going to go to our scripts folder, and let's create a separate folder here. Right click, create folder. Let's call it weapons. And I'm going to use this folder to store all the scripts that regards the weapons. So I'm going to open the weapons, right click, create a C# script, and we want to create here a weapon renderer script. So let's call it weapon renderer. And let's open this script up in Visual Studio. Great. This will be similar to what we have in our player. So let's delete the content of this script. We can add here require component, since this script will take care of the sprite renderer. So let's add parenthesis type of. And we are going to add another parenthesis sprite renderer. And we are going to place this component on our weapon or on our assault rifle sprite, and this will drive how the assault rifle is being displayed. So we will need to create here a serialized field. Let's create protected int player sorting order. Okay, let's set it to be 0. So this will be important parameter, since we never know what is the sorting layer number or index of the player. And if our player is sorted on the layer 0, then we can make our gun go to the layer -1, holding the weapon above our player's head to render this weapon behind our player avatar. And when we are going to hold the weapon in front of our player, we are going to place the weapon on the layer with index greater than the player avatar, so we make sure that our weapon is always rendered in front of our player when it is pointing downwards. So that's why we will need this value. Next, we will need to have an access to protected sprite render, and we are going to call it sprite weapon render. Okay, again we can call awake just like we did in our player and get the reference to it. So weapon render equals get component of type sprite render, and we will want to have two methods here in this file. First one will be public void flip sprite, and we are going to pass here bool value, and this method will make our sprite, our weapon renderer, flip the y-axis. So we are going to call weapon render dot flip y equals val. So when we are pointing to the left, we are correctly rendering our weapon to be correct in the correct position, not upside down. Next, we are going to create another method, and this one will take care of changing the sorting order. So let's create public void render behind head. Okay, we are going to pass here bool value val, and here we are going to check if val, we are going to call weapon render dot sorting order equals our player sorting order minus 1. So this will make sure that if we want, we can sort our weapon behind our player's head. Else, we want to set the same value. We can omit the parentheses since we only have those two statements. Let's copy this and sorting order, player sorting order plus 1. Okay, and this will ensure that we can render our weapon in front or behind our player avatar. Now, we will need to call this component from somewhere. So I'm going to reopen the agent weapon. I have it opened in Visual Studio. So open up the agent weapon. And in this script, we will need to get the reference to our weapon render. So underneath the desired angle, let's add serialized field attribute in the square brackets. And let's call protected weapon render. Let's call it weapon render. Great. Now what we will want to do is to create another method that will take care of rendering correctly our weapon. So inside our aim weapon, we are going to, underneath the desired angle, create adjust weapon rendering. This will be a new method. So alt enter on it and generate this method inside our file. And we can change the definition of it to be protected if we want to modify it in some cases. And what we are going to do here is we are going to call our weapon renderer. We are going to add a question mark to check if it is not null, because at some points it might be null, so we are not going to call it then. So if weapon renderer is not null, we are going to call flip sprite, and we are going to check if desired angle is greater than 90 or desired angle is less than minus 90. And I will explain why it's so. And let's call another method on weapon render question mark to see if it is not null. If it isn't, we are going to call render behind head, and in this case we are going to call desired angle is less than 180 degrees and our desired angle is greater than 0. Okay, and now let's go back to Unity and let me explain what is going on. Great. What we are going to do is go to our player, open the game object, and choose the weapon parent. And let's take a look at the rotation in the inspector. If I'm going to rotate our player above 0, we can see that we are pointing above our player's head, and it happens until we reach 180 degrees. So if the value of the angle is between 180 and 0, we want to render the gun behind our player's head. And now another thing is if we have the angle above 90 degrees or below minus 90 degrees, in any case, we want then to flip our weapon. So let's choose our weapon parent, extend it, choose assault rifle and flip the y-axis in the sprite renderer. And you can see that only now it is rotated correctly. So I'm going to uncheck it. And this is how we are going to make sure that our weapon is correctly rendered. So I'm going to choose our weapon parent and reset the Z value. And now what we can do is we can attach our weapon renderer to our assault rifle. So let's go to scripts, weapon, and let's drag our weapon renderer into our assault rifle. Our weapon parent already has our player weapon, which extends the agent weapon. So now what we can do is simply click play, and now our weapon should be rendered correctly. So let's see. And we are missing something. So we need to stop the game and we need to open up our weapon, our agent weapon script. Great. And I have forgotten to assign this weapon renderer. So what we are going to do is create a wake here. And what we are going to call here is our weapon renderer equals get component in children. And we are going to get the weapon renderer here. Since we always want to get it, and we might want to create a method here to swap weapon that will automatically get it if we ever swap a weapon. So maybe we will want to refactor this further, but for now this should be enough. So let's save it. Let's go back to Unity. Great. So now finally we should be able to press play and our gun should be assigned our weapon, and now it is correctly rendered above our behind our head. And if we go to the left, we can see that our weapon is rendered correctly, so it is flipped on y-axis and it gets flipped when we are pointing to the right. So it all should work fine and it looks great. So now what we can do is to make sure that we can shoot, we will need to implement some changes to our agent input. So see you in the next video. In the previous video, we have implemented a way to render our gun correctly. Now, what we would like to do is to get an input from the player if the player wants to shoot. And to do that, we are going to again utilize the Unity input system. So to go to you can go to the top menu, Edit, Project Settings, and in the Input Manager, you can see that we have those axes, one of which is Fire 1. And we can use this to get the input about if we want to fire. Now this is great, but we do not have any way to get this input. So to make changes to our project, we need to go to our scripts and open up our input, our agent input script. So let's open it up in Visual Studio. Great. What we will want to do here is we are going to add a field. So let's underneath the private camera, main camera, add a private pull fire button down. Equals false. Great. And I'm going to explain it in a bit. And another thing that we will need to add is two Unity events. One will be responsible for calling if we are pressing the fire button, and one will be responsible for calling if we are releasing the fire button. So let's copy one of those events and Ctrl+C and paste it underneath. We are going to delete the vector2 return value or value that we want to send. Instead, we are going only to call Unity event, and instead of on pointer position change, we are going to call on fire button down or pressed. We can again copy this event and paste it below and change the on fire button pressed to on fire button released. Okay, we can format the code a bit. And those two events will be called when we are either holding or releasing our button. So to check if we are doing this, we are going to slide down to the update and call get fire input. Since we do not have this method, Alt-Enter and generate it in our file. Let's slide down to find it, and here it is. Now, the issue that we are facing is that we want to use the Unity access. So we want to get access row like we did for our player. So if our input, so this is the Unity input system, dot get access raw, and we want to type here string value fire1 or whatever you have in your input in the project settings for the fire1, and we want to check if this is greater than 0. And if it is, we would like to call our on fire button pressed question mark to check if anybody is listening to it. If it is so, dot and invoke. But there is one issue. Let's add the else statement. Do not forget on fire button released question mark dot invoke. But the issue that we are facing now is that if we are holding the button, it will constantly call this event. If we are releasing the button, it will always call this event of releasing. And we do not need to call this as often. We want to call it once. And to do that, we are going to utilize our Boolean flag implemented at the start. So we are going to check if our get access row for fire1 is greater than 0. We are going to check if our fire button down equals false. Then we are going to call our fire button down equals true. So we are assuming that we are starting off with a fire button up. So we are not pressing a button. If we are pressing a button, the game will not register. You will need to let go and re-click it. We are calling the fire button is true. So only if our fire button is true in the else statement, only if our fire button is down is true, we are going to call our fire button down is false, and we are going to call on fire button released. So now we should only call once those two events, and this is what we would expect from clicking a button. So let's save it. Now we need to test this behavior if it works correctly. So what we are going to do is let's go back to Unity. Great. And since in any case we will want to create an additional script for our weapon, we are going to create inside our scripts folder, inside our weapons, let's right click and create a script. Let's call it weapon. And let's open this script up in Visual Studio. Great. Now this script will be responsible for firing bullets from our weapon, and this will drive most of the conventional weapons that we want to implement. For now, we are going to only implement two methods, so let's delete the update and start. And what we are going to do is create public void shoot, and we are going to simply debug that log here, and in quotation marks shooting. Great. Let's copy this method and let's paste it below, and we are going to call stop shooting this method, and we are going to call in the debug.log statement again stop shooting. And this is just a placeholder for our methods that we will implement to this script. So let's save it. Let's go back to Unity. Great. Let's choose our assault rifle from our weapon parent, and let's drag to the assault rifle game object our weapon. And now what we can do is go to our player game object, and in the agent input we should see two additional events. Let's add to each of them a listener using this plus icon. Let's assign our assault rifle, and for the fire button pressed, let's choose a function weapon, and let's choose the shoot. And for our second on fire button released event, we are going to again assign our assault rifle, no function, choose it, and choose from the drop down weapon and choose the stop shooting. And now when we press play, we should see that if we press right mouse button or hold it, it will print only once shooting, and if we let go of it, it will call stop shooting, and it will never call it more than once, both of those log statements. So this means that it all works great. Now we have a way to get the input of about shooting from our player. Now, as I have mentioned previously, I want to use our weapon parent and its player weapon script, or rather agent weapon script, to control if we are firing or not. So our player should call only the agent weapon or player weapon script, and in turn this script will detect if we have a weapon and it will call on it shoot. So that's what we are going to do in the next video. We are going to refactor the setup so that if we by any chance do not have a weapon equipped, we will still be able to call our shooting mechanic, and it will prevent the game from crashing in case we do not have a weapon assigned. Okay, so see you in the next video. In the previous video, we have created this weapon script that has shoot and stop shooting methods, and we have attached it inside our player game object inside our weapon parent to the assault rifle, and we have tied it to our player to the agent input script. And I do not want it like this because in case we do not have this script, our player will try to invoke our methods on a script that is not active. So it might throw us some errors, or if we do not have a weapon or switch it, we cannot really assign back to our player agent input those listeners. So instead, what we are going to do is we are going to edit our player weapon, or actually the agent weapon script, and we are going to use this in order to call shooting on our weapon script. So let's do it. I'm going to re-enable the assault rifle, and let's go to our scripts folder, and let's open up our agent weapon script. Great. We are in our agent weapon script, and what we will want to do is we will want to create another serialized field. So let's type serialized field, and we are going to create protected weapon, and we are going to call it weapon. So this will be the reference to our weapon script. Now, in the awake, we will want to get the reference to our script, and as I have mentioned before, we may want to refactor this code as a separate method. So let's type weapon equals get component in children, and we are going to search for a weapon. And actually, let's select those two lines. What we can do is right click, and we should have this quick action and refactorings menu, and we have this extract method. So we can create a new method out of those two lines, and let's call it assign weapon. So basic idea will be that if you want to change a weapon, we may want to reattach a game object or instantiate a new weapon game object inside our weapon parent, and then simply call this assign weapon method to get the references to it so we can use this weapon again. Okay, now we want to slide down after getting the reference to our weapon. We want to create here two new methods, and those methods will be called by our agent input, or rather we are going to assign them to our agent input events. And this will be public void, and we are going to call shoot, and we are going to create another one, public void stop shooting. Okay, and here in the shoot method we are going to call our weapon dot, and we have, I think, shoot method here, and in the stop shooting we are going to simply call our weapon dot stop shooting. But at some points of time we may have a null here instead of a weapon, so maybe there is no object of type weapon attached as a child, or we haven't found it, or it was never attached for some reason. So to check it, we should add a question mark before we call dot shoot and a question mark before we call dot stop shooting, and this question mark will simply check if weapon is not referencing a null value. If it is not null, we can be sure that we can call on it shoot and stop shooting. And this is the idea behind calling this agent weapon to perform the shooting, and we are only going to call the shoot on our weapon if it exists. Okay, that's it for our agent weapon. Let's save it and let's go back to Unity. And now what we can do is go to our player game object, and let's make sure that our agent input in the event of onFire button pressed have the weapon parent assigned. So let's drag it into our onFire button pressed on the only event listener, and let's choose the function on our player weapon, and let's choose the shoot method. Let's do the same for our on-fire button released. So let's drag here weapon parent instead of assault rifle, and let's call the function player weapon and stop shooting. Now, if we press play, and sometimes you might have this error, and this is connected with grid paint palette window. So what you can do is simply close this tile palette. So right click on it and close. If you have it opened, stop the game and clear the console and replay the game, and now it should not appear. And now we have the same functionality that we had previously. So now, if we stop the game and we delete our assault rifle and try playing the game, we will still have the same functionality because we are checking with question mark if it is not null. Now, unfortunately, it will not work if I will Ctrl Z to re-add our assault rifle. And if we press play, we are getting the shoot and stop shooting debug.log statements. But if we delete our assault rifle, so remove it, we have this missing reference exception. So let's go to our scripts folder and let's reopen our agent weapon script. Great. And what we can do here is slide down and make sure that whenever we are calling weapon renderer, we will add if weapon renderer is not null. And now it will work for both cases. Okay. And let's put this logic inside it. So now the question marks are redundant because we are explicitly checking for a null reference exception. We can copy this, or actually we can create another if statement inside our shoot. So if our weapon is not null, and let's copy this if statement and paste it below as well. And now we are safe. We can delete those question marks, and we are safe that even if we delete the weapon from our game object, we will not be calling those methods. So let's go back to Unity. Okay, I'm going to clear the console. First of all, I'm going to delete the assault rifle, and let's press play and let's check if everything is working fine. And it is. I'm going to stop the game, Ctrl Z to re-add the assault rifle. And now I'm going to press play. And during the gameplay, I'm going to delete the assault rifle, and it still works. So this is what we are talking about. Now we are safe from errors in case that our weapon was destroyed. Now, of course, it will not prevent us from having the angry players because they cannot fight monsters. But now our game will not crash. So that's great. Now in the next video, let's add some more logic to our weapon script so we can control how much ammo do we have, and we can add some delay to the shooting so we can keep shooting like an automatic rifle would by printing the message every period of time that we will preset in our script. And we are going to use the coroutine to delay our next shot, and we are going to stop shooting when we call our on fire button released. So see you in the next video. In the previous video, we have refactored our setup a bit so that we now are using in our agent input the weapon parent, the player weapon is assigned as the listeners to our on fire button pressed and released, and the player weapon, or rather the agent weapon currently, is making sure that we have the object of type weapon as its child, and that we can call shoot or stop shooting on it if it exists. So now we are safe that our game will not crash in the event that we take away our player's weapon. So now, what do we want to do is we want to create some logic in our weapon script so that we can simulate a assault rifle, so the automatic rifle shooting mechanic. But one important aspect of designing your game is designing the data for your game. So what I would like to do is I would like to already plan some values for our weapon that will be stored as a data inside our data SO as a scriptable object. So we are going to start from creating a small object called weapon data SO inside our data SO inside our scripts folder, just as a placeholder that we will fill with the appropriate data fields when we create our weapon script. So let's create in our data SO, right click, create script, and let's call it weapon data SO. Okay, we can open it up in Visual Studio. Great. And all we want to do here is let's delete everything in this script. Let's, instead of inheriting from mono behavior, inherit from scriptable object. And let's add at the top of this class an attribute, so square brackets, create asset menu, open parentheses, type menu. You should have the menu name equals tip, so enter to create it, and let's create in the parentheses, in the quotation marks, weapons slash, and we are going to call weapon data. So this will be the folder inside our create menu that will be created for us so that we can create this asset. And that's it for now. Let's save this and let's go back to Unity. Great. So if we did everything correctly, we should be able to right click, create, and we should see the weapons and weapon data. We are not going to create one right now because what we want to do is go to our scripts folder, open our weapons folder, and let's open up the weapon script. Great. Now, just to mention it, designing the architecture of your game, so the data, the script layout, takes some time. So for the sake of time, I am skipping those steps of designing those structures, but basically you would have created first the weapon script, implement all the logic in it, and then figure out that you might want to have a logic such as agent weapon to drive the shooting instead of the weapon because you might want to switch it, and then you might figure out that you need some data for each weapon, so each weapon shoots differently, so then you will create the scriptable object. I just hope that after seeing how we do it in this course, you will have a better understanding how your code might end up looking like. But don't worry if you have everything crammed in one mono behavior, you can always refactor the structure later. For now, we have our two methods here, shoot and stop shooting. We are going to start from implementing fields into the script. So what we will want to have here is we will want to have a way to instantiate a bullet at the end of our gun and making this bullet fly. Well, the bullet itself will be controlled by another script that will make it fly in the direction it was shot, but we will need to have a reference to the end of our gun. So we are going to create serialized field attribute, and let's type protected game object, let's call it muzzle. So this will be our game object that we will create at the end of our gun, so at the muzzle of our gun, and we are going to assign it to our weapon script, so the weapon script can instantiate there the bullets. Next, what we will need to have is let's create prop full snippet, tab twice, and we are going to have a private field of type int. Let's leave the parameter as is, but let's name it ammo. Move to the name of the property and let's type capital A ammo. So this will be the ammunition that our weapon has. We are going to add here the attribute serialized field so we can see how much ammo do we have, and let's change the private to protected. Great. What we can do is we can assign this ammo, let's assign it to be 10 for now. And inside this ammo property, what we are going to do is we are going to add some code to our set method. So properties allow us to add some code, and when we are calling the property, we can call this get, and we are going to get this field ammo. But when we are setting it, we can add some logic to clamp the value. For example, our gun cannot really have more ammo than this amount, or maybe our ammo is limited and this gun uses this ammo and there is a limit to how much we can carry. So if we pick up a package with ammunition, we want to call ammo and set it to this value, or plus equals this value that we have picked up. And then in our set method, what we can do is we can check. We can call ammo equals math f dot clamp, and we want to clamp the value, which is the value passed to us to this ammo property. Let's delete the line below. So we want to clamp this value, and we want to clamp it between 0, so we cannot really have less than 0 ammunition, but we also want to call our data file that we will have, and it will tell us how much ammo can we carry. So let's create above this ammo a serialized field attribute, and let's call it protected weapon data so. Let's call it weapon data. Great. And now what we can do is we can type in our mathf.clamp value, comma 0, comma, and we can type weapon data dot ammo capacity with capital A. And since we do not have it, we can alt enter on it, and we can see that we can generate variable ammo capacity, and we can generate property or a field. I would like to create a property, so let's choose this generate property weapon data SO ammo capacity. And now we are filling in this weapon data SO object or scriptable object with all the data necessary by our weapon script. Great. We are going to expand this logic by adding some events to where the ammo is changing. When the ammo is changing the value, we will need to inform our UI interface about it so we can display how many bullets do we have still. For now, that's it for this ammo property. Now, since we have this shoot and stop shooting, I believe we will need two Unity events, because when we are shooting, there can be two occurrences. Either we have bullets, and this means that we will shoot. So maybe we want to play some sounds on shoot, or maybe add some feedback. And instead of modifying this weapon code, we will add an Unity event, and we will call this event. And then whoever wants to listen to this event will be listening. So we can split the code into separate classes. So for example, our feedback will be in a separate class, and it will be informed that we are shooting, and then it will make, for example, our muzzle flash. We are going to create an event here above our shoot, but make sure that the events are below every property that you have in your code, so this is much more clear what is in our inspector, what is shown in our inspector. So let's type prop, tab twice, and we are going to create public. Let's change the type to Unity event, and we do not have it, so alt enter and click using Unity event, Unity engine events. The library will be imported at the top of our class, and now we have our Unity event. It will be called on shoot, and this will be called when we are calling the shoot method. Let's add to it an attribute, so square brackets field colon, and we are going to call serialized field. Great. Okay, I have made a mistake here. Now there might be a different event. So what happens if we have no ammo? Well, certainly we want to inform our user about it, our player. So we would have some kind of event. So let's copy this event, let's paste it below, and let's type on shoot no ammo. So maybe we want to play a different feedback sound when we have no ammo, and we do not want to flash our muzzle for certain. Great. We will need one more property here, so let's, above the Unity events, create prop, tab twice, let's change the int to bool, tab twice to move to the name, and we are going to call it ammo full. Enter. And we are going to delete the set method and delete the semicolon near the get using the spacebar, and instead we are going to use lambda expressions, so equal and greater sign, and we are going to call here our ammo property. So if our ammo is greater or equal to our weapon data.ammo capacity, let's finish this line, this will mean that our ammo is full, and this will be useful when we want to pick up ammo packages from the ground. So if we have enough ammo, we will not pick them up. Great. And last thing that we will need to do in this episode is underneath the events, let's create start method. And what we are going to call here is our ammo property. We are going to set it to our weapon data.ammo capacity. So at the start, our weapon will have full magazine, so we have all the bullets that we need. So the weapon will have full magazine at the start of our game. Okay, I think that's enough for one lecture. In the next one, we are going to finish off implementing some methods to our weapon script. So see you in the next video. In the previous video, we have implemented some parameters and fields to our weapon class. Now make sure that you save your scripts. You can use Ctrl-Shift-S or File, and I believe there is Save All button here. If you have any issues, usually some scripts are not being saved when you work on them. Now we have our fields in our weapon script. Now it is time to create some semi-automatic and automatic shooting logic, and then we will implement some bullets and make it visually appealing. In the previous video, I have not implemented two important fields here in our weapon script. So above the Unity events, we are going to create two variables. First one will be protected ball is shooting equals false. This will be a flag used when we are shooting, and we are going to set it true if we are shooting. So if player holds our shoot button, it will be flagged as true, and every time after a delay we are going to perform a shot. But if it is a semi-automatic rifle or a pistol, for example, if we hold our button, the flag will become false after first shot, and the player will need to re-click the fire button to keep on shooting. So this will be important. Another one will be, let's add attributes, so square brackets, serialized field, and we are going to create protected full reload coroutine. And let's call it, let's set it to be false. We are going to use serialized field flag on it so we can see in case we want to debug our code. So in our game we will not have the reload as we have in the 3D shooters, rather we will simulate it by just waiting a bit before we can shoot again. So what we are going to do is we are going to start a coroutine, set this flag to true, and you will be able to see in the editor if by any chance this isn't kept true. So it will be much easier to debug your code in case your shooting fails. Great. So now we will slide it down, and we have our two methods currently, the shoot and stop shooting. What I want to do is, instead of shoot, I'm going to use Ctrl+R to rename this, and I'm going to rename it to try shooting. And this is because our weapon might not have enough ammo. So we are going to call try shooting, but it doesn't necessarily mean that we are going to shoot. We may get the on shoot no ammo event called, and in this and this is why I have chosen to rename it to try shooting. And inside this, we are going to simply call our is shooting flag, and we are going to set it to be true. Great. And again, in stop shooting, we are going to simply call this flag and set is shooting to be false. Great. Now, to reload our ammo, let's create a public void, and we are going to call reload, and we are going to pass here int ammo, and this will be a simple method. We are going to call our property ammo. Always use the property plus equals our ammo, because our property has the logic for checking if we are not setting too much here as the ammo value. Next, what we will have here is we are going to create an update method. So let's type update. This will be the standard Unity update, and here we are going to call use weapon. And we do not have this method, so alt enter on it and generate this method inside this class. Now the reason we have it is because we are setting those flags. We are going to perform all our shooting in the update. So if our flag is true, we are going to try shooting. So what we want to do here in our use weapon, we will want to check in the if statement. We're going to check if is shooting is true, and if our reload coroutine is equal to false. So we are going to only perform a shot if we are shooting and we are not waiting for the reload. Great. Now here inside this if statement, we are going to check if we have enough ammo. So let's type if ammo property is greater than 0, and we will have if and else statement. Great. So let's start from the if statement. If we have ammo, we are going to reduce the ammo. So ammo property minus minus to reduce by 1. We are going to call on shoot event question mark to see if anybody is listening dot invoke to call this event, so we can play some sound and invoke some feedback for the player, so there's some particles, for example. And next, what we are going to do is we are going to call for tab from the snippet to create a for loop. We are going to loop for I equals 0, tab to move to the length, and we are going to call our weapon data, and we are going to call here dot get bullet count to spawn. And this will be a new method that we will need to have in our weapon data. So Alt enter on it and generate this method, and it will automatically generate a method that returns an int value. So this is a useful way to create your methods without typing explicitly private void or private int and the name of the method. And what we are going to do here is we are going to call shoot bullet. Again, this method is new, so Alt enter and generate it. Now, when we have shot a bullet, we are going to perform a wait operation. So we are going to start a coroutine that will wait a bit before we can repeat it. So we are going to basically set the reload coroutine to true. Now else, if we have no ammo, we are going to call is shooting to false, since we are not going to retry it if we do not have ammo. Next, we are going to call on shoot no ammo question mark if anybody is listening dot invoke. Great. And we are going to simply return. Okay. Now, if we have not returned in this else statement, we are going to call finish shooting method. And this method, to be exact, will call our delay. So finish the statement, Alt enter on the name, and generate this method inside our file. Okay, let's slide it down. Here we have our finish shooting method. So finish shooting. Okay. We are going to call here a start coroutine, and we are going to create a coroutine called delay next shot coroutine. Okay, we can alt enter on it to generate this method, but it will not generate the proper method definition here. In any case, after we are calling this coroutine, we are going to call if our weapon data dot automatic fire. So we are going to store the data about if the weapon is semi-automatic or automatic. So if this automatic fire is equal to false. Okay. And we can now alt enter on this automatic fire since we are checking if it is false. So we're going to again alt enter and generate property inside our weapon data SO, which will automatically create a property that returns a bool value. And we are going to call here, if this is not an automatic weapon, again we want to call is shooting equals false. So this means that our player will need to re-click the fire button to start shooting. Great. Now let's take a look at our coroutine. So this is not a proper definition of a coroutine. It will be protected. It will return I enumerator. So that's why the coroutine runs, because of the I enumerator, but we are not going to dwell about it in this course. And we are going to here want to call our reload coroutine equals true. So this is our flag. Now it is angry because we are not returning a value, so we will need to call yield return new, and we are going to type wait for seconds, which will suspend the time of the execution of this method, just like we would create a thread. And we are going to wait for the value of seconds that we pass here, and before we can reset the reload coroutine to be false. So again, we are going to utilize our weapon data. We will have something called weapon delay. Okay? Again, we can alt enter on it. And since Unity knows that we are expecting a float here, it will automatically create for us a float value. So let's generate property weapon data so.weapon delay. Great. We are going to call reload coroutine equals false. And only now we will be able to perform a next shot, which will automatically call this coroutine to restart, and we are going to continue this. So the only value that will drive how fast we are shooting will be this weapon delay. For now, in the shoot bullets, we are going to again debug.log and let's debug.log shooting, or maybe shooting bullet, a bullet. Since we do not have a prefab for the bullets, so we are going to add some logic to the script later on. So I think so far each and every method that we have created have some code in it. We have created a lot of code. So make sure that you Ctrl Shift S, because now you can see that this asterisk near my weapon data, the so.cs have the asterisk, so it is not saved. So if I go back to Unity, it might throw me an error. So I'm going to use Ctrl Shift S, and all the scripts were saved. So now let's go back to Unity. Okay, and in the next video we are going to fix or add some code to our weapon data SO before we can create our weapon datas, and we can assign one of those to our weapon script so we can perform some shooting and we can test how our logic works without spawning a bullet for now. So see you in the next video. In the previous video we have implemented some code into our weapon script. So it has now on-shoot and on-shoot no ammo events, and it requires us to provide it with muzzle and with weapon data. So what we can do is, let's quickly create a muzzle here. So let's click on our assault rifle inside hierarchy. Let's right click, create empty, and this will be our muzzle representation. What we can do to make it more visible is we can click in the inspector on this box, and we can select an icon for it. Let's choose this green icon, for example. And now we should be able to view it if we turn on gizmos in our scene view. You can see that it is pretty big. No matter, we can still use it. We can click on gizmos, extend it, and uncheck these 3D icons. So now everything will be smaller. Great. Let's recheck this game object in the hierarchy. We can rename it to muzzle. Great. We can choose the move tool in our scene view, and we can move it towards the end of our rifle. So somewhere here the bullets will be spawned. We can spawn them a little bit closer or a little bit further. Do mind that if you spawn bullets here and the enemy will be real close, you will not hit it. So this is something worth considering. In any case, make sure that your position on Z stays as 0, because when you are spawning your bullets and your bullets are spawned on a different Z position, they might not hit your colliders in 2D space. So we have this game object. Let's go back to our assault rifle to find our weapon script, and let's drag our muzzle to the muzzle game object field inside our weapon script. Great. So what we will need to do now is to create this weapon data file. So we can already do this. So let's go to our assets, to our data, underscore data, and let's create here, right click, create a new folder, and let's call it weapon data. Since if we have multiple guns, we want the data about them to be in a separate data folder. Let's open this folder, let's right click, create weapons, and let's create weapon data, and let's call it assault rifle data. Okay, or maybe even assault rifle weapon data, so we know exactly what it is. But unfortunately it has no parameters to be set, so we will need to fix our weapon data SO. But for now we can choose our assault rifle and assign our assault rifle weapon data here. Great. And let's go back to our assault rifle weapon data asset, and we can double tap on this script field, and we should be able to go to our weapon data SO script. Great. Now what we have here is our ammo capacity, automatic fire, and weapon delay. Let's set our ammo capacity and other properties by adding to them field parameters, so field, colon, and let's type serialized field. So this will expose those parameters in our editor, in our inspector, while keeping them as properties so we can manipulate how we set them or what we get from them. Now, what we can do is as well is to set for our ammo capacity, for example, that it will be equal to 100. And in addition to that, so this is the default value. And in addition to that, we can add here range. And we can add range. Again, we need to copy this field, colon, and add it. So range will be associated with the field. And let's add a range of from 0 to 100, for example. And now we will be able only to assign this much ammo to a weapon. Of course, you can modify it if you don't find this range to be big enough, but this prevents us from setting the value less than 0. So this gives us an ability to not set the amount of ammo to be minus value inside our weapon script. Next, we have automatic fire. And of course, we can delete this internal from the set. We do not really need it. For automatic fire, let's set the default value to be false. So we do not want all the weapons to have automatic fire enabled by default. Next, we have our weapon delay. Again, this is a good place to add another attribute called field, and range, so that we do not have a very big delay here. So let's type 0.1f, and we are going to add comma and 2f. So we are going to have delays in this range. So maybe you have a different range, but still you can change it inside our weapon data SO script. And let's set the default delay to be equal to 0.1f. Okay, next, I would like to add another one of those properties. So let's type prop, tab twice. We are going to have float, tab to move to the name, and let's call it spread angle. Enter. So this will be the angle of spread of our bullets. So each weapon usually have some spread. So we are going to add it to this weapon data SO, and we are going to get it when we are spawning the bullets. We are going to add a random angle to our angle at which we are shooting the bullets, so we can have some spread for our guns. Let's set the default value to be 5, and we can copy those attributes field, serialized field, and field range, and let's paste them above our spread angle, and let's change the range from 0 to 10, where 0 will be no spread and 10 will be big spread. Great. In addition to that, we will need to have some private fields. So let's create serialized field attribute, and underneath it let's type private bull multi-bullet shot equals false. So in case we want to implement our shotgun, we will want to check it to true, so that our weapon will know that it will need to spawn multiple bullets instead of only one. Great. And next we need to have another serialized field attribute and add private int, and let's create bullet count. So this will be set to 0, and basically what we are going to do is we are going to set how many bullets should be spawned per one ammo. So this will say that if we are shooting a shotgun, maybe we want to shoot 5 bullets for 1 ammo. Next, what we are going to do is we are going to use our get bullet count to spawn value, and we are going to check here, instead of throwing an exception, we are going to check if our multi-bullet shoot is equal to true. We are going to return our bullet count. So this is the count that we are using to say how many bullets should be shot. Else we are going to return 1. And we can add to our bullet count a range. So let's type attribute range, and let's again set it from 1 to maybe 10. So maybe I have made a mistake to set it to 0. Let's set it to 1 by default. So we do not want to shoot less than 1 bullet in case we have a multi-bullet shot. Great. And now we should be done with this script. So let's save it, Ctrl S, and let's go back to Unity. Great. So now if you select your _data weapon data folder and choose the assault rifle weapon data, you should have all the parameters available for you to set. Now it is up to you how you set them, and you can see that ammo capacity has 0 value. So this is because we have created the script later after we have added new code. So if we create a new weapon data, it will have ammo capacity set to default 100 value. Okay, so let's delete this additional one, and our assault rifle weapon data will have 100 bullets. Our weapon delay, let's set it to 0.1. Let's set automatic fire to be true. Spread angle, let's set it to something less, so maybe 3. A multi-bullet shot is checked to false, and bullet count is 1. So this is great. So we have this weapon assigned, weapon data assigned to our assault rifle. And yes, it is assigned. We have ammo set to 10, but it will be set to 100 for the ammo capacity. So let's press play and see if it all works. I'm going to select this assault rifle and press play. So first of all, we should be able to see that ammo should be increased to 100. Now if we hold our button, we can see that we are printing a couple of shooting a bullet statements. So I'm going to clear it. I'm not going to collapse those statements. And I'm going to shoot the bullets. We can see that ammo is being decreased. We are printing those shooting bullet statements. And we can hold our button until we have 0. And if our ammo is at 0, we can clear the console and try shooting again. And nothing really happens because we have no code for it. But now we can see that our code is starting to do something. So in the next video, let's try creating a bullet prefab that we will be able to shoot from our gun, so that we have some visual feedback that our code is really working. Okay, so see you in the next video.